Welcome back, everybody. So today we're on day 3, I think it is, of the ray tracing series that I'm doing. I'm building a program in Rust to do ray tracing, so ray tracer, and I'm following this tutorial here called Ray Tracing in One Weekend. If you haven't seen any of the other videos, there's 2 other ones there. But basically what I'm doing is breaking this into sort of 6 sections, and I'm doing sort of 2 sections a day. I'm a little bit behind schedule because of life and work and other things, but we're making some progress. So I've got 2 videos out covering the first 4 sections. Today what we're going to do is go through through section 5 and 6. And so if you want to go and follow along, go and check out the previous videos. I have a GitHub repo which kind of covers all the stuff that we're doing. So this has all the code in it, and we're going to basically start from where we were here. And so today, adding a sphere. Now effectively what we'll do is we'll go through this part of building a sphere, which is pretty easy, and then we'll build this normal map, and it's a color map for the normal around the sphere, and then we'll end up with some kind of image that looks like this. So it should be a bit of fun, and I think the majority will be, getting our heads around this sort of surface normal and the color map for that. So that should be a bit interesting. So in the previous video we really just sort of did this simple background, but it was building rays and it was tracing them. But anyway, let's have a look. So I'm not going to go through the theory here. I'd encourage you to have a look at it. For any of you that have studied, high school maths or college, university maths, you'll be familiar with some of this. It sort of goes through how you define a sphere. In this case, a sphere is defined like this: x squared plus y squared plus z squared equals r squared. And then around a center, cx, cy, cz, this is the equation that you use. It goes through this other approach, which I won't go through. But effectively what we're trying to do here is to build a ray tracer that knows how to draw a sphere. We need to know how to find the intersections from the camera through an object like a sphere, right? So the sphere isn't sort of technically there. There's no geometry that we're really building, right? That's not what a ray tracer is doing. In a 3D game, you build a mesh or you build some other thing and you draw that as an object. In this case, it's all we're doing is we're basically firing rays off from the camera into the scene, and then working out where those intersections happen. Now, the key for that is that you can effectively solve a quadratic equation to work that out. And if you get no roots, then there's no intersection. 1 root, then it's just hitting it's a tangent, basically. And then 2 roots, you're getting an intersection. And so what this code does is effectively hard code that maths into a function called hitSphere, and then we update the color to return red when the sphere is hit. So you'll basically end up with what looks like a round circle, but that's only because we're looking at I guess one side of the sphere. Which side, I don't know. And so anyway, you don't get any sense of volume or 3-dimensionality here, but that's the very first bit. And then then when we get into the surface normals, that's where we'll actually start seeing some representation of the volume or the object itself in 3 dimensions. And so that will be the second section. So let's get into it. So what we need to do is, it looks like we need a hitSphere function. Right. All right, so let's do that. Let's build one. Unresolved module. Okay, cool. All right, so what we'll do is above here, or just under here, we'll do function hitSphere, and that will have something called the center, which will be a reference to a vec3. It'll have a radius, which will be a float, and it will have R, which is a reference to array. And it should return bool. Okay, so that's how you do that in Rust. Okay, so these ampersands are references basically, and bool is a type that's not known. Oh no, it is good. So we could just say something like, to satisfy that, we could just return false always. Okay, so that should solve that. And then down in vector, down in color, what we can do is we can say, so we have the ray, and so what we do is, do we have the center? We'll just pass the center that way. Okay, anyway, we're assuming the center is here, and then we'll pass in a radius there and the ray. We'll return red. All right, so basically what we're going to do is say, oops, in here, I'm going to say if hit sphere, and then it's a new vec3, which is 0, -1. Then we have, hang on a second, -1.0. Okay. Radius is 0.5, and then we have r. So if this is true, and we actually don't need these parentheses in Rust, so a little bit less syntax there. If it does hit, then we return a new vec, which is red and no green and no blue. All right, that should be right. Nice. Oh, except that's not working. Mismatched types expected. Okay, wants a reference. And then this thing should be floats. Cool, so that should be good. So that's just going to make everything that hits the sphere red. All right, now we need to complete the hit sphere. So, well, we could try running it, I guess. Remember, we're just piping everything, or sorry, redirecting everything to out. I'm going to run GIMP, which is probably the least efficient way to do this. But at least GIMP will let us open PPM files, and so we'll should just get a blue background, hopefully. Yep, so this is our 200 by 100 pixel PPM file. Awesome. Now, all right, now let's work out how to find the intersection. All right, so in here, what we're doing is we're finding the origin. Well, we're building a vector which is the origin to the center. So let's call, so it's called OC. Origin minus, and then center. But we can't subtract these. Oh, can't subtract, really? Okay, we didn't build subtract. All right, so what I've done here is I've overloaded these operators, previous videos again, and we have built our own operators for our vec3 class. And so the way we do that is we build one called sub, and it's for vector. We'll just call it sub for vec3, and then we'll need some kind of output, which will be self, which is vec3. And then we'll need a function which does the subtraction, and so self represents the left hand side, and then the right hand side will be self again, and then we'll output self output. And then basically what we need to do is create a new vec3 which basically subtracts pairwise. I think. Yeah, I think so. Minus, oh my god, E1, E. v2. Okay, should be something as simple as that, providing that that's actually correct, which I think it is. And so center, it expects a struct, but it found a reference. I guess that's okay. I guess we can just dereference it like that. Should work. Or not. Mismatch types. So center is reference to vec3. Well, I guess the easiest way is to do this, which isn't great, but it should work. And then, anyway, and then we need let a equal, now what is dot? We don't have a dot function, so we need to go and build that. So dot is defined down in here. So dot is just adding up. Okay, so we'll go back to vec, and then we need a dot. So we'll implement this inside the, this is a method basically, isn't it? No, it's not a method. So we'll just do pub dot, pub function dot reference to, v1, which is a reference to vec3, v2, which is a reference to vec3, and then what does it do? Just does v1 dot e0 times v2 e0 plus v1 e1 v2 e1 plus v1 e2 v2 e2. Okay. Which returns a vec, right? Oh, float, sorry. Okay, so that should work. Should be good. All right, now we should be able to go back into here and say, where are we? Okay, so we want vec3 dot r dot direction. R dot direction, and these should be references. Jesus. Oh my god. Okay, I can't type today by looks. Alright, so that should give us A, let B equal 2.0 times by dot OC R dot direction. Again, should require references here, and then this will be vec3. Okay. Okay, and then let C equal, okay, so vec3 dot, again we'll need OC minus radius times radius. Okay, and then we've got then we'll have a discriminant. Discriminant equals b times b minus 4 times a c. Okay, so that should work, but why not? 4.0. Okay, and then we should just be able to say return if discriminant is greater than 0. Awesome. So that should be pretty straight. Oh, dot 0. It's flow. Okay, that should be pretty easy. That should be quite correct, I would think. So now we can just run that again and see what happens. And then in GIMP we can just reload it. We should get a red circle. Okay. So not very exciting, but hey, we got a circle. So we can now render a sphere, apparently. We just don't get any dimensionality. So let's go and build the normals. So a surface normal is basically perpendicular to the surface, like a tangent of a surface in 3 dimensions. And so the way that they do this is they basically take what is it, P, which is a vector, or the direction vector, and then they subtract C, which is the radius of the sphere, or equal to the length of the radius of the sphere. So hit point minus the center. Yeah. Visualize the normals with a color map. Okay. Because it's easy and somewhat intuitive to assume n is a unit length vector, so each component is -1 to 1, is to map each component to the interval from 1 to 0 and then map x, y, z to RGB. For the normal, we need the hit point, not just whether we hit or not. Let's assume the closest hit point small as t. These changes in the code let us compute and visualize n. Okay. So for a given ray, I guess we're going to find all the intersections, find the smallest t. We're going to do all the intersections from the center out. So OC is going to be the origin minus the center. A, B, and C. So if the discriminant is less than 0, we return -1. Otherwise, we return minus b minus the square root of the discriminant divided by 2 times a. Okay. Okay, let's have a look. So we've got this. Now what we need is, if the discriminant is less than 0, then we return -1. Otherwise, we do return let's do -b minus the discriminant, square root of the discriminant, divided by 2 times a. Okay. -1. It's not bool anymore, it's a float. Okay. And then color changes, so obviously we can't do this anymore. So we'll do let t, which is a float, equal hit sphere, and it's still that vector. Okay, so we'll do let t equal that. then if t is greater than 0, what's this complaining about? Expected bool. Huh? Doesn't make any sense. I think it's confused. All right. Then what do we need? We need let n equal, it's a vector anyway, so let's do, we haven't got a unit vector. What's unit vector? All right, so we're filling out our vec class based on the functions we need. So do we have unit vector? We did. Okay, cool. So we've got that. So it's vec3 unit vector. Okay. Which will then be, okay, so we've got r dot point at parameter t minus vec3 new 0 minus 1 right, and then we return 0.5 times by vec3 new, and then this complicated looking thing. Well, not really. N dot x plus 1, n dot y plus 1, n dot z plus 1. I've still got unit vector. Oh, what's this complaining about? Right, that will need to be, what is vector? It must, unit vector takes a reference. All right, so okay, and then what's this one complaining about? It's almost like we need to reference the whole thing once we've subtracted. It's a bit messy. Now this thing is complaining because we haven't implemented float. It's fine, we'll just do it this way. But this error is because we haven't implemented float times vec. We've implemented vec times float. Now what we could do is this, but that's going to get quickly annoying. So that would work. But ideally we want to be able to do this as well. And so we might as well just go and do that. So what we did down in our vec class here last time was we implemented vec times float, but not float times vec. So in this case, what I'm going to need to do is something like that. Now the type, the output, going to be vec3. Still need a function multiply, but self should be float 32 this time. Right hand side should be vec3, and I'm returning self output. And so in this case, when we build the vec3, it should be should just be E. Should be the same thing, except it'll be right hand side dot E0 times by self. Oh my god, self, right? And so we'll do this across each element. Self right hand side dot E2 times self. You get the idea, right? And so this now implements the same thing so that we have commutativity. We can commute those operations, so it'll work on either side. All right, so that's fixed that problem. And in fact, we'll probably want to do that for divide as well. So let's go and just get that done, because I'm sure we'll want to do that as well. So ops divide vec. Huh, already did that, did I? So I did sub. No, I didn't. Okay. So let's go and do that. So implement ops divide for float 32. Again, so the type will be still vec. We'll still want a divide function like this, but we'll need vec3, and we'll still output vec3, but in this case it'll just be something like basically, well, is this right? Doesn't make sense. Would we ever do that? I don't think we would. Would we? Do we ever need to do that? A number divided by a vector. Doesn't make any sense. All right, I'm smoking something here. All right, great. So let's go back to our original code here. We had this block completed. Now, I think that's correct, isn't it? So T is still that. Yeah, should work. Let's see what we get. So we'll run it again. We'll reload. Let's see what we get now. So we should get a color map. It looks something like that. Looks good, I think. It's a little bit, yeah, it's just a little bit more vivid, right? Haven't made any mistakes here, have I? Hang on. Let's return that. Otherwise, tease that. Yeah, looks okay. All right. So that's our color map. That's the color map of the normal. Or is it color normal map? I don't know. So we started there, we built this thing, and then we've got this thing now. All right, great. So let's see if we can build more than one sphere. It's tempting to have an array of spheres. Very clean solution is to make an abstract class for anything array may hit, and make both a sphere and a list of spheres something you can hit. What would, okay. Surface, hittable abstract class. So in Rust, you don't get abstract classes, and typically in C++, abstract classes provide an implementation as well as an interface, at least from my memories of C++. And so in this case, what they've got is a class Hittable with a default that implements this hit method. Okay, and then they build a sphere class that extends that abstract class, which means that it has to implement the hit method. So in Rust we don't have this option, but basically what we're trying to do is ensure that we satisfy an interface. And so the best way that I know how to do that in Rust is to use a trait. So if you look at Rust traits, you'll see some examples. So you've got an animal trait that does, name, noise, and talk. It has a default method definition. So the sheep. Okay. You can implement the trait for the struct. Right, in which case it has to have name, noise, and talk. Okay. And so you can use the trait. So the trait has new. But it's a sheep. Yeah. So just anyway, in Rust, the traits are a way of kind of building shared. It's like defining an interface that needs to be satisfied if you implement it, and so we'll do that. So what we're going to do is we'll create a new struct called hit record, or we'll call it Hittable. I think it's called Hittable.rs, and then there was another one here called sphere. So we need a sphere.rs as well. Now Hittable is going to be called Hittable, and then we'll implement Hittable, and it's going to have this public function called hit that all it does is take array reference. It's going to have something called tmin. It's going to have tmax, and it's going to have a record, which is a hit record. Okay, reference to a hit record struct, which doesn't exist yet. Oh, what? Oh, okay. Oops. All right, it should be hit record. I'll do it like this. Hit record. And then it returns bool. So it looks like the default they want is false. Now inside of here we've got T, P, and normal. All right, so this is a new thing that we can use. We do need access to the vec3 class, or vec3 struct, and the same for array. Because if we start to use this, and we say, use hittable hit record, needs to be public. Okay. Hit record. Unable to import. It's not very nice. Public struct hit record. Hit record is private. No, it's not. Did I not save it? Didn't save it. Whoops. All right. So so now we've got this hittable thing. Now what we need is a sphere. So we'll do the same thing here. Might as well pull in what we know we'll need. So create vec3, ray, and then probably hittable. hit record. I'm guessing. So this thing will be called sphere. We'll implement the hit record trait for sphere. So that's basically what we're doing. So this is saying that it extends the abstract class Hittable, which we can't do, but we've got a hit record trait. But is it, I wonder if we should call it, oh, I'm an idiot. Hang on a second. Goodness gracious. So what we need is a trait here, not a bloody implement. Okay. And what we need to do is, the trait is called Hittable. Okay. And then I guess the function is public because it's implied. Okay. So that's what we need. Sorry. So we still have the hit record, and we can still implement methods on that if we want to. In fact, we probably will implement getters or something, so we don't have to make all the members public, or we could do that. And then we've got a hittable trait, and that's all defined inside of the hittable module. That's better. And so, okay, and so back in sphere, we probably want all of it. Do we? We'll work it out. I don't know if we need hittable. We need hit record. Hang on a second. We're implementing hittable for sphere. So let's just grab everything in hittable. And so this thing means that we have to have a hit method, which was, you know, reference to array, tmin was the float, tmax was the float, and rec was a reference to the hit record, and it returned bool. Okay. Although, why is it saying unnecessary? If you say so. Is it really unnecessary? Why is it unnecessary? Because we're implementing a trait that's public? Guess we'll find out. All right. And so we can implement that later. But at a high level, these are the bits that we need. And then, oh, what's this? A hittable list. So a hittable list looks like it's a pointer to an array of hittable. Okay. So it's like it's a vector. So okay. So we need one more module here called hit. Let's just call it hittable list, I guess. And then here we've got a struct called hittable list. Oh, sorry. Hittable list, and then we implement hittable for it, which means we have to have a hit method. It satisfies the same things, so array, tmax, tmin, tmax, and record, which is a hittable hit record. Okay, which means up here we need to do the same thing, use create All right, so what's in the struct? So this is interesting. So this is a list. So list is a pointer to an array of hittable. Yeah, I don't like that. I'm going to do a vec. So I'm just going to do something like this. Vec of hittable. Can I do that? Hittable. Something like that. Except that's a trait. Anyway, we'll work out how Russ is going to complain about this. Anyway, all right, cool. And then down in here we construct the list. Okay. Wow, just to get two spheres. Looks like we built two spheres, one really large one, one small one. Okay. All right, got some coding to do. Wow, all right. So we got our, let's go back. We got our sphere class. Sorry, got our float hit sphere. We built our hittable trait. Then we were going to implement the sphere class, struct module. So in this case, we've got a couple of things. We've got a center, which is a vec3, and we've got a radius, which is float, and a constructor. So we'll do sphere center, which is vec3. So these, anyway, so I'm passing everything by value here, which isn't great. And then radius, which is a float, and it returns a sphere, presumably. And so in this case, it's going to look something like center is center and radius is radius. Okay. So that's saying shorthand struct radius f. Anyway, what is that? Shorthand struct initialization. Just shorthand struct initialization. Wow. Really? Just do that? That's cool. There you go. That's pretty neat. All right. That was worth looking at. Okay, just learned something new. All right, so this builds the sphere. It stores our state, center, and radius. We've got a hittable implementation, but it's empty, so let's build that thing. So this is going to get interesting. So let OC equal R origin minus center minus self. Okay, and let A equal. Hang on a second, I've done this. Is that? That's what this is, right? What can we just pick up from here? The whole thing? Okay, let's just pick up the whole thing. And put it in here. And then get rid of hit sphere. Don't think we need hit sphere, do we? Where's it called? Okay. Anyway, we'll work that out. Okay, so so we've got this. Looks good. If discriminant is greater than 0, then do all this stuff. Okay, so it looks like we've got new logic. So discriminant is greater than 0, then do that. Let temp equal, I've got this. No, it's not that simple. Okay, and then if temp is less than Tmax and temp is greater than Tmin, then okay, so rec has to be mutable. So we need to be able to do r dot t. Okay. Right. So this needs to be pub, apparently. I don't really like doing that, but hey, let's do that for now. So that should mean that we can go rec.t equals temp, rec.p equal r.pointer parameter, rec.t, and then rec.normal equals rec.p minus self.center divided by self.radius. And then we return true. So temp needs to be mutable. Then we go temps equal to minus b plus the discriminant, square root of the discriminant, divided by a. And then we do again temp less than Tmax and temp is greater than Tmin. Rec.t is equal to temp, rec.p is equal to r.pointer parameter, rec.t, rec.normal is equal to rec.p minus self-center divided by self-radius. What's the difference there? It's the same code. Great. And then otherwise, what do we do? Return false, apparently. Okay, so that is implementing the hit function for sphere. And so if we get any of, so remember the discriminant basically is the roots. And so if we get any intersections at all, either a tangent or not, yeah, I have to come back to what that actually means. I'm not sure. we'll look at that. All right, so what we want to do is implement this hittable list interface now, or class rather. So we've decided to forego the need for, we don't need list size because Vec gives it to us. Hittable's a trait, so that'll be interesting to know what Russ thinks of that at compile time. And then we'll do this this hit function, hit method. Again, it's got to be a method, and then so we're gonna implement something called temp rec, which is going to be a hit record, which we don't have a new for, but we could probably do a default. We could probably just derive default here, maybe. Let's see. Can't. Why not? Because we don't have default for vec3. We can do that. We should be able to derive default. Nice. So we should just be able to do this now. Can't we? Can we just do that? Isn't that doable now? Yep, looks like it is. Nice. So this should just be, Rust will just probably do the right thing. We can check that. And then what we want is let hit anything equal false. So that'll be bool. And then we want, so that's bool, right? Must be. And then we've got let closest so far equal tmax. So that's double precision. Is double, so C++, double keyword, 64-bit, double. We're using float 32. Oh. $64 bits. Oh well. They're using float 64. We're doing float 32. So what? Okay. So then what we're going to do is we're going to say for object in the list. If object hit, okay, so rtmin closest so far, and then the temp hit record, then hit anything will be true, closest so far will be the length along the hit record, which is hit record has length, direction, and normal. Where are we? I'm totally lost. Okay, and then rec is going to equal temp rec. Can I just do that? Doesn't seem right. Oh well. And we just return whatever hit anything is. I think what we need is use hittable list. All the stuff. It's not what? Declared type module. hittable list. It's going to break now. Lots of stuff. What's going on? Cannot find type hittable in this scope. Okay. Apparently that's okay. The trait wasn't public. That's why. So we'll still do. Let's be explicit about it. Oh wow. Okay. So list size for values of type cannot be known at compile time. Din. So I need to box it. Init box. Into an object. Why not? Without an explicit din. Why not? Because it needs to be a reference or cannot be made into an object. You need that though. Okay. So apparently we're not using vec3, so that's good. So we'll get rid of that. Found for struct. Not a method. Okay, I'm totally confused here. So here I've got list, which is a vector. So just like this. Can I just do that? Can't be made into an object. All right, let's have a look. Let's when in doubt, read the documentation. Dynamically sized types in the size trait. That's helpful. Boxed in trait would work too. I think I need to box it. Box, why can't I box it? Why doesn't that work? Pointer for heap allocation. So it looks like it couldn't turn the trait into an object because I didn't have a reference to self. So I've got that now, and now what's going on here? Mismatch types. Hit temp rec is So record, yep. So I need to borrow that, but I can't borrow it twice. Can I? No. So that will work, but then, will it work? Doesn't seem to work. Oh, it does work. But I've already borrowed it. That's going to complain, surely. Aren't I borrowing it twice there? Oh, but it's not mutable, so it's fine. Okay. All right, and then hit sphere. Cool. Oh, all right, well, let's see. Cool. Let's go back. So it looks like we might have built that. So let's go and check out what main needs now. So vec color. We're doing the same thing. So let's do let rec equal hit record default again, I guess. What's world? Okay, need to go back down here. Let's see how this is used. So up here we're going to have, we're going to build something called list. So let list equal, what? Oh, I don't need that, do I? It's a vector. Let's do that. But it's a vector of hittable. So list should have something like this type. But that won't work. It's got to be is it? I think it's got to be this type, which looks really ugly. Hittable's not in scope. Okay, so we need a hit record and a hittable trait. What's in hittable list? Yeah, whatever. This needs to be public. This needs to be okay. So this just needs to be a hittable list. So this thing should be where am I? So list should be a hittable list. Hittable list. But there's no constructor for that. But there needs to be. Getting confusing. All right, so let's implement hittable list. This is getting a bit convoluted, but anyway, let's implement hittable list because we want to basically take we want to be able to build. It just takes a list, right? Do we even need this? I guess so. So in this case, it's going to be... Is it really going to be this? And then it's going to be like that, right? Sorry. Hittable list. And then this thing is going to be hittable list. What? Pub. New. And then, goodness gracious. This is going to be the world. This is going to be a vector, but the type I think it's going to be this. I think something like that anyway. And then we'll need to do list.push, and it'll be a new hittable, which will be a sphere, so it'll be sphere new, which will be 0.0, 0.0, and then minus 1.0. 0.5. And then we'll need really? Didn't use sphere, mod sphere. Use sphere. Okay. Called it something else, didn't I? What was I thinking? Gonna break everything else. Yeah, interesting. Now I won't be able to borrow these two together. Fantastic. So temp rec needs to be mutable. So mutable reference, my bad. But this will break things because I can't borrow two mutable references. Anyway, let's see what breaks. So why is this complaining? Cannot find center. Really? Isn't that the whole point? We can just do this shorthand. Center. What? Say what? That should be okay. Why can't, oh, because I bloody can't spell. Okay. Okay, and then main. What's going on here? I've got to call this sphere. But that needs... Are you joking? I made it freaking private. Okay, and then this thing. Box. Do I need to box it? Doesn't make sense. Box. Looks like I need to box it. How do I box it? Can I just do that? Jesus, this syntax is getting awful. Is it standard box? No. Hittable new. Not sure how to box. Guess we'll need to Google it. This looks ugly as hell though. What's this syntax box? How do I do box? Rust box. Standard boxed box. Box new. Okay. So we've got a world, and then what do we do with the world? Oh. Down in here where we construct the ray, we need color and then pass in world, and then world, excuse me, needs to take a hittable list. Let's do a reference shortly. Reference to a what's it called, world. So that should just call, pass in the world. So we've got two elements in it. This is really kind of ugly syntax though, isn't it? Not happy about that. Anyway, and then up in color, we need to modify what happens here. So we built this hit record, and then we said if the world, so if world hid, and then it's the ray starting at 0, going to standard float 32 max, and rec. Okay. What's this? Complaining about. Needs to be a. Okay, needs to be a reference. So if we get a hit, then we return 0.5 times by this new vector, which is rec.normal.x plus 1.0 rec.normal.y plus 1.0 rec.normal.z plus 1.0. Okay. If not, then we still do unit direction. We still do the same thing, and we return the same thing. So it should be like that. But I don't know if we need return here. What have I done? That thing needs to be there. Don't think we need any of that anymore. Let mute. It's not declared. I guess it should be mutable then. Whew, okay. Oh, yep, sure. That needs to be mutable. Absolutely. Okay, now what's this complaining about? Cannot move out of self.list, which is behind a shared reference. So maybe we can just do a slice. But then we've still got this problem with can't borrow it as mutable more than once. Can't use it because it was mutably borrowed, and we've already borrowed it. Oh, rec is immutable? Shouldn't be. Huh. Never used. This is the fun of the borrow checker, making sure we're not doing anything naughty. Let me just see. I've got something else that I tried earlier. See if we can get that up so I can check it. Did I? No, I don't think I made it available. Let me try something. I was playing around with this earlier today to make sure that I could actually make some progress. And I did run into this problem before. What did I do to solve it? So I built some getters and setters. So the problem is what we're doing is we're borrowing this variable temp rec as mutable more than once, right? So within the scope. So as we loop over it, Rust is complaining about that, and you can only borrow a variable mutably once in a scope, right? For a given lifetime. And so I was trying to remember what I did. I think the way I solved that was by just doing something like this. So what I had here was I built a getter called T. I built a setter. Closest so far. Did a setter for P, something like that, I think, and then setter for normal. And then that sets up rec basically. And then what I kind of need to do here is go and implement all these things. So you implement hit record, and you build these public functions. So one of them is you take a reference to self, and then you do you literally do self.p equals P. Oh, sorry, that's a getter, right? So that's the kind of the pattern. T obviously returns a float instead. So, oh fuck, what am I doing? Normal. So then you do, I'll change all of this. This will need to change as well. But, you know, it's pretty easy. So it's literally like this. Anyway, and then back in Hittable, you do some setters as well. So it was pub function set P, and then it was mutable reference to P, to self. So we could set p, and that returns the same thing. Well, actually, we'll call it value vec3. So that was the pattern there. And then we'll do set t similarly. And then normal here as well. That's vec3. That's cool. And so in this case it was self dot p equals p. So it should just be that equals val. Self dot t, and then self dot normal. Okay, and then back in here. Spell. Cool. And then back in here we just set up these. So we do set t to not to the temp value. And we do the same thing here. So we do set p value. And then likewise set the normal here. P is a getter now. So it should be like that. Something as simple as that. That gets around the problem, which is a lot of mucking around. I'm sure there's a better way, but that's how I got around it. Anyway, so let's go back to our main again, main program. So now we've got color, which takes array, and a hittable list, which is our world. The hittable list is kind of ugly, but it's this vector of boxed hittables, and then we just push. We box these spheres, which is a real shame, right? Like, I think it's because of the trait. Like, we shouldn't need to box that. But I think because the trait isn't, the size of the trait's not known at runtime, we can't get around that, so we have to put it on the heap. Sorry, it's not known at compile time rather, so we have to get around it by putting it on the heap. Anyway, and then we pass in the world, which is a reference to the hittable list, into our color function, and we should be good to go. So anyway, let's see what this builds after all of that work. Okay, so we just want to reload it. We've got a complete buggy thing. Isn't very good. Oh dear. You know how they say that when your Rust program compiles, it usually works? Well, it does, but it doesn't mean that there's not logical bugs. And so totally screwed that up. Okay, so what have I done wrong? Okay, so it's because I've got the same object. It's not going to work. And then it needs to be 100 wide, otherwise that won't make any sense at all. Okay. Okay, let's try that again, now that we've actually got a different object. Okay, this should look different. Let's see what it's done. Oh, beautiful. Oh, it's still got some issues though with how we're rendering our sphere. That color map's all screwed up. We've definitely got the big sphere, which is this big thing at the bottom here, and then the sphere above it is totally screwed up. Wonder why? What have I done there? So it's 0, 0, minus 1.5, 0, minus 100.5, minus 100, and then we do U and V, and we can still get the same ray. And the color is the same. What's P? Is P actually used? I don't think P is used. Is it? Let P equal vec3 new. Oh no, sorry. R dot, what is it? Point at parameter 2.0. It's not even used. Weird. Not sure why that's in there. Anyway, and then it passes in the ray, builds all the rays, passes in the ray and the world, and then world. If the world if we sort of intersect the world from 0 to the maximum value of a float, a 32-bit float, we return half times by vector 3. So rect normal x, y, and z, or z, and then we let the unit direction equal unit vector times by r direction. T is equal to half times unit direction y plus 1, and then returns 1 minus t times 111 plus, oh yeah, that's right, t 05.71. Okay, that looks good to me. So I think that logic's correct. Now, Hittable's not doing anything weird, is it? So normal. Let's get Hittable list first. So we've got a struct, which is a vec of these Hittables. We can create a new one. Actually, that should probably be a reference or something, ideally. But anyway, and then we implement Hittable. So we've got self ray tmin tmax hit record. And so we build this temp rec, hit anything flag, closest so far, and then we loop through all the objects, of which there are only 2, and if we get a hit, then we set that we've found something, we set the closest so far, and then we update rec. With this, anyway, it shouldn't matter. Temp rec dot t. Cool. So we take temp rec t. Work normal. TP and normal. So P returns P, T returns T, normal returns normal, set P, set T, and set normal. It's doing my head in. And then sphere just sets radius and center. Then OC is the origin minus the center. A is the dot product of R direction and R direction. OC, sorry, B is not 2 times anymore. It's weird. So B is just the dot product of OC and R direction. C is the dot product of OC minus blah radius. Discriminant's B squared minus A times C. Got some bugs in here, eh? If the discriminant's 0, temp is minus B minus the square root of the discriminant all divided by A. If it's less than max but greater than min, then set the T to temp, set the P to point a parameter of T, set the normal to P minus center divided by radius, and then return true. Likewise for the other case where it's minus B plus square root of discriminant divided by A. If it's less than max or greater than min, do the same thing. Yeah, it looks all right. And then return true, otherwise return false. I don't think we've got any of the maths wrong. Don't know. Let's have a look. Vector. Let's have a look. Yeah, so it was the maths that I had wrong on the... So after all of that, thanks for bearing with me. If you made it through to this point, by the way, you need an award, I think. So it was basically the maths that I was doing. Where was it? It was here in how I was working out whether or not I'd hit a sphere. I had the wrong maths. In fact, I think probably the intermediate step where I was just rendering this thing was wrong as well. Anyway, it certainly looks right to me. So wow, that was epic. That was a lot more epic than I expected. So we've got something. What have I just done? I've minimized everything. That was clever. So yeah, we've got something that looks right, doesn't it? And wow. Okay, well anyway, so you can sort of see what's going on. I haven't got a really good intuitive understanding of all the maths yet, but I'll look into that and I'll understand that better in the next one. What I'm going to do next is start with 7 and 8. So, you know, we've done the first 6. 7 is going to be anti-aliasing. I've looked at this already. In fact, I implemented it quickly today, most of it anyway. And what it does is it just takes lots of samples and averages those pixels so that you end up with a sort of a blurry edge, and so you get this kind of you get these edge pixels that look a lot smoother. And then we're going to implement diffuse materials, which is all about sort of randomizing the way that light bounces off a material, and so that's it's reasonably straightforward to do that, and we'll end up with something that looks kind of like a matte kind of gray image like this. And that should be fun. So we'll get that done pretty quickly. I think this was a long one, right? There was a lot of programming, plus I was mucking around with, you know, the borrow checker telling me I was doing the wrong thing. But we did end up with the right result. Hey, so, you know, pat ourselves on the back for that. Look, I know this is probably a lot longer than maybe some of you wanted to watch, but you know, it'll vary in length. I'm going to try and stick to these 2 segments every video anyway. So look, let's make sure that we've got we got? Git status. So we want to add all of our source to that. Might as well add the data as well. And we're going to commit it. We'll say, what have we got here? We're rendering spheres and our world and building color normal maps to visualize the world. And we should be good. So thanks everyone. Please go and check out the code. It's all in the GitHub repo here. So I've just uploaded it, so you should be able to see all of the new code that we've just implemented. Quite a long one. Implemented lots of different objects and modules today. If there's any questions about any of it, please put a comment down in the video. I'm going to link to all this stuff in the description. If you like what I'm doing, even if you think it's hilarious how wrong I'm getting everything, please just hit the like button. I'd love to know that you're enjoying it, and then subscribe if you want to sort of follow along. Follow along. It should be a lot of fun. Remember, we are going to get to a general ray tracer at the end of this in Rust, and learn a lot along the way. So thanks heaps for joining me, and see you in the next one.